This is section 1.6, and it is about absolute value equations and inequalities. And there are 5 objectives for this particular section. Number 1 is to simplify expressions that contain absolute value symbols, then to find the distance between 2 points on the number line. The third part is solving equations with absolute value expressions. And then we solve equations with 2 absolute value expressions. And then we'll solve some inequalities with absolute value expressions also. First of all, let's define absolute value. So the absolute value of x, denoted by vertical line x, vertical line, is defined as follows. X is greater than or equal to 0 if the absolute value of x is equal to x, and if x is less than 0, then the absolute value of x is equal to minus x. This may sound a little confusing, but as we do some examples, I'm sure it'll become much clearer. So the properties of absolute value are the following. The absolute value of a product is a product of the absolute values. In other words, the absolute value of A times B is the absolute value of A times the absolute value of B for any real numbers A and B. Then, similarly, the quotient, the absolute value of a quotient, is the quotient of the absolute values. Absolute value of A divided by B is equal to the absolute value of A divided by the absolute value of B for any real numbers A and B, and where B is not equal to 0, because we cannot have 0 in the denominator, because division by 0 is undefined. I'm sure you remember that. Okay, then the absolute value of minus A is equal to the absolute value of A for any real number A. In other words, the absolute value of the opposite of a number is the same as the absolute value of the number. So let's work with these concepts here to answer some of the questions in the following problems. So for the first exercise, the absolute value of 7x would be equal to 7 times the absolute value of x. 7 is positive, but we don't know about x, so that's why we have to write it this way. For number 2, the absolute value of x to the 8th, we can write as x to the 8th, because x to the 8th is always non-negative. It's an even exponent, so in other words, we are multiplying two real numbers, and the product of two real numbers is non-negative. Why do we say non-negative? Because 0 is included, and 0 is not positive, but so we say it's a non-negative expression, x to the 8th. Then number 3, 5a squared b absolute value. Well, 5 is a positive number, and a squared is also a non-negative number. And so we just don't know what b, so we leave b and the absolute value between the absolute value symbols. By the way, absolute value symbols are another example of grouping symbols, like parentheses are grouping symbols, and absolute value symbols, signs rather, are grouping symbols also. Then for number 4, we have the absolute value of 7a divided by b squared. First of all, we know that that's equal to the absolute value of 7a divided by the absolute value of b squared. Okay, so here we can write the numerator as 7 That's a positive number, but we don't know about a, so we leave that in the absolute value symbol, between the absolute value symbols. Make sure it doesn't look like 17. And in the denominator, well, b squared is a non-negative number for sure, so we can write that without the absolute value symbol. And then for number 5, which would be 5, move it up so you can see, 5 was absolute value of minus 9x. Well, we can write that as the absolute value of minus 9 times the absolute value of x. And the absolute value of minus 9 is 9. So 9 times absolute value of x would be the correct answer for number 5. Here's the relationship between distance and absolute value. For any real numbers a and b, the distance between them is the absolute value of a minus b. In other words, the distance between two numbers is non-negative. It's a very important definition. You may want to keep that in mind. So let's apply that definition to this exercise number 6. So we are supposed to find the distance between minus 6 and minus 35. So we do take the absolute value of minus 6 minus negative 35, which would be minus 6 plus 35. A double minus means a plus, right? If a minus is preceded by another minus sign, separated by parentheses, of course, that's a plus sign. And then minus 6 plus 35 is 29. And, excuse me, and the absolute value of 29 is 29. So that is the distance between minus 6 and minus 35. So to compute the distance between 19 and 14, we simply write this as the absolute value of 19 minus 14, which would be the absolute value of 5. And the absolute value of 5, of course, is 5. Or we could also write this as the absolute value of 14 minus 19. So that would be the absolute value of negative 5. And we know that the absolute value of negative 5 is equal to 5. So either way, the answer is 5. And here the distance between 0 and p, where p is a real number, so 0 minus p would be the absolute value of minus p, and so that would be the absolute value of p. As we had seen before, the absolute value of a is the same as absolute value of minus a. Next, we'll look at the absolute value principle. It says for any number, for any positive number p and any algebraic expression x, the solution of absolute value of x equals p is those numbers that satisfy x equals minus p or x equals p. The equation absolute value of x equals 0 is equivalent to the equation x equals 0, and the equation absolute value of x equals minus p has no solution. And why is that? Well, the absolute value of any real number was defined to be a non-negative quantity, And so here we have a negative quantity. So if that's a requirement, then that equation has no solution. This is really quite important, as you will see in the future with some of the exercises. So, make a note of this. And I will refer back to this one, to this third property. So then in number 9, we are asked to solve the absolute value equation, absolute value of x equals 6, and we are supposed to graph this in the number line. Well, based on what we just saw here, the absolute value of 6 means x is equal to 6, or x is equal to minus 6. So plotting this on the number line, here's minus 6, and here's 6. And so now we graph this on the number line. The 2 points, 6 and minus 6. Here's 6, and here's minus 6 on the number line. And what about number 10? Solve absolute value of x equals minus 6. Well, the absolute value of a real number cannot be negative, so here the solution is the empty set. And the absolute value of p equals 0 means the solution set is 0. And by the way, in the previous example, we could write the solution set as minus 6 and 6. Let's solve the absolute value equation 12. Absolute value of 3x equals 6. So absolute value of 3x equals 6. That means that 3x is equal to 6, or 3x is equal to minus 6. So dividing both sides by 3, to isolate x, we find that then x is equal to 2. And here we divide by 3. Then x is equal to negative 2. So the solution set of this equation is minus 2 and 2. So that's for number 12. We can solve number 13 in a similar way, where we have 4 times absolute value of x plus 10 equals 27. We subtract 10 on both sides. Then we have 4 times absolute value of x equals 17. By dividing both sides by 4, we now have isolated the variable by canceling the 4's. So absolute value of x equals 17 divided by 4, which means x is equal to 17 divided by 4, or x is equal to minus 17 divided by 4. So then for number 13, our solution set is minus 17 divided by 4 and 17 divided by 4. So here's our solution for number 13. Beginning with 4 times absolute value of x plus 10 equals 27. And here's the corresponding solution. We do number 14 in a similar way. 3 absolute value of x minus 2 equals 10. We add 2 to both sides to isolate the term with the variable. So it gives us 3 absolute value of x. And on the right side we have 12. So now we divide both sides by 3 to isolate the variable. So the 3's cancel. We have absolute value of x. And 12 divided by 3 equals 4. So then the solution would be x equals 4 or x equals negative 4. That would be the solution set to 14. So we can write it as minus 4, 4. So number 15 says, solve the absolute value equation of absolute value x minus 4 equals 1. And so the two methods in example 1, the first one was to say, okay, we know we are 1 unit away from 4. So the distance between 4 and whatever that number is equal to 1. So in other words, we go 1 to the left, and there's 3 here. And then 1 unit, so 1 unit to the left and 1 unit to the right. That gives us 4. That gives us 5. So based on that, our solution set is 3 and 5. Okay, so that's one way. That's one of the ways to do it. The other way to do it is to say, okay, we have absolute value of x minus 4 equals 1, which means that that x minus 4 is either equal to 1 or x minus 4 is equal to minus 1. So we solve these equations. In this case, we add 4 to both sides. So x equals 5. And here we add 4 to both sides also. So we isolate x on the left side, and on the right side we have 4 minus 1, which is equal to 3. So again, the solution set, doing it this way, is also 3, 5. Let us do number 16, a guided solution. So here we have the absolute value of 3x minus 4 equals 17. So we know that that's equal to 3x minus 4 equal to minus 17, or 3x minus 4 equal to 17. To isolate the term with a variable, 3x, we add 4 to both sides. And minus 4 plus 4 is 0, so that isolates 3x. And by adding 4 to 17, we get minus 13. And here we add 4 to 17, we get 21. And so here we divide on both sides by 3. And so by dividing both sides by 3 to isolate our variable, we get minus 13 divided by 3. And on the right side here, dividing by 3 again to isolate x, 21 divided by 3 is equal to 7. So then the solution set is minus 13 divided by 3, 7. That's where that 7 comes from. By now, the solution to an absolute value equation like this should be obvious. The absolute value of 6 plus 2x equals negative 3. The solution set is the empty set. because the absolute value of any quantity is non-negative. So there is no solution to this absolute value equation. Let's do exercise number 18. So here we have the absolute value of 5x minus 3 equals the absolute value of x plus 4. So that simply means that 5x minus 3 is equal to x plus 4, or 5x minus 3 equals minus x plus 4, which of course is the same as 5x minus 3 equals minus x minus 4. Solving each one of these equations, we subtract x on both sides. So we get 4x minus 3 on the left side, and on the right side we have 4. Then we add 3 to both sides. So we have 4x equals 7, or x equals 7 divided by 4. That's one solution. And for the other one, we add 3 to both sides. So we have 5x equals minus x minus 1. Then we add 1x to both sides. So 5x plus x is 6x equals negative 1. Dividing both sides by 6 to isolate x. Then we find that the 6's cancel and x equals minus 1/6. So these are the two solutions. So we can write our solution set as minus 1/6 and 7/4. That would be the solution set of this absolute value equation. So let me just write the solution set: minus 1/6 and 7/4. And I just showed you how to arrive at the answer. We do number 19 in a similar way. That means x minus 3 is equal to x plus 10, or x minus 3 is equal to the opposite of x plus 10, which means x minus 3 is equal to minus x minus 10. So for the first equation, we find that when we subtract x on both sides, we find that negative 3 is equal to 10, which of course is false. So in other words, this equation, this one here, does not have any solution. The other one, though, when we add x to both sides, we get 2x minus 3 equals minus 10. Then we add 3 to both sides. So that means we isolate the term with a variable. We have 2x. And on the right side we have minus 7. So then we divide by 2 on both sides. So the 2's cancel. We isolated x as minus 7/2, or 7 divided by 2. And in this case, that's the only solution to this absolute value equation, minus 7/2. Because, as I mentioned before, the first equation here does not have a solution. So here the solution set is equal to minus 7/2. You're coming back to this equation. Some equations do not have a solution. So far we haven't really encountered that, but this is a good example of where it can happen. as I showed you when you subtract x on both sides. Then we wind up with a statement minus 3 equals 10, which of course is false. In other words, this equation does not have a solution. But fortunately, the other one does. For exercise number 20, we can write down the solution right away. X equals 5 or x equals negative 5. So that means on the graph, we have the solution here at minus 5, and the other solution is at plus 5. And then the solution set would be minus 5, comma 5. Now, the inequality now, number 21, I hope that you looked at the book before you look at number 21, what this symbol means, and that is why I mentioned that on page 103, there are the three main absolute value equations and inequalities that you know what that is. This means that x is between 5 and negative 5. If you look on page 103, under B, you have that statement. So that means here, now we have the parentheses at 5 and at minus 5. And the solution is everything in between. So we can graph the line between or make it a little bit heavier. So this is, oops, sorry about that, our solution here. And the solution set we can write this way. The set of all x such that x is greater than minus 5 and x is less than 5. And in interval notation, it would be the interval from minus 5 to 5. Okay, number 22, again referring back to page 103, under C, it tells you what the solution is in a case like this. This inequality means that x is greater than or equal to 5, or x is less than or equal to negative 5. Okay, so in other words, negative 5 is here and gets a bracket because it's a less than or equal. And all the numbers to the left of minus 5, including minus 5. So that's our solution here. And for the other one, it's x greater than or equal to 5. So we start at 5 with a bracket, and it goes all the way to the right, the powers of infinity. And so the solution set we can write as a set of all x, such that x is less than or equal to negative 5, or x is greater than or equal to 5. And if we write it in interval notation, it would be the interval from minus infinity to minus 5, bracket, parenthesis, union is the interval from 5 to powers of infinity. So here we have the set notation, and here we have the interval notation for the solution, and here's a graph. So here's a special note for you. Please note on page 103 are the solutions of absolute value equations and inequalities. So that here you find the three types of absolute value equations and inequalities. Be sure you study them and understand them. So that is on page 103. Let me just highlight that for you to say, okay, this is important. Okay, that's what that is for. Based on the information on page 103, we can solve this inequality as follows. We can write that as 2x minus 3 less than 7 and greater than minus 7. So this is a compound inequality. And so the idea is to isolate the variable. So that means we add 3 to all parts, to each part of the inequality. So minus 7 plus 3 is minus 4, less than 2x, and 7 plus 3 is 10. We divide each part of the inequality, compound inequality by 2 to isolate the variable x. So then we get negative 2 less than x less than 5. So we can graph this by putting a parenthesis at minus 2 and another parenthesis at 5. And this then is our solution set in form of a graph. And in set notation, we can write it as the set of all x, such that x is greater than negative 2 and less than 5. And in interval notation, we simply write it as minus 2 comma 5. Let's do the guided solution, the guided example here, number 24. Absolute value of 7 minus 3x less than or equal to 4. So that means, based on information on page 103, that means that 7 minus 3x is greater than negative 4 and less than 4. To solve this compound inequality, we subtract 7 in each part of the inequality, and minus 4 minus 7 is minus 11, but 7 minus 7 is 0, so that only leaves us a minus 3x in the middle. And so when we subtract 7 from 4, we get a negative 3. Now to isolate x, we need to divide each part of the compound inequality by negative 3. So we get minus 11 divided by minus 3, and minus 3x divided by minus 3, and we get minus 3 divided by minus 3. But since we are dividing an inequality by a negative number, we need to turn the inequality symbols the other way. So they now go in this direction. Okay? So minus divided by minus is a plus, so we have 11 thirds greater than or equal to x, greater than or equal to 1, because minus 3 divided by minus 3 is positive 1. So we typically turn that around, so the smaller numbers on the left. So our solution set then is the set of all x such that x is greater than or equal to 1 and less than or equal to 11 thirds. And in interval notation, we have a bracket at the 1 because we have the less greater than or equal. And here we have another bracket next to the 11 thirds because we have a greater than or equal symbol also. And then on the graph, we would go from 1, there's a bracket there at 1, this is this one here, and 11 thirds, that's about 3 2/3, so it's almost 4, so 3 2/3 is about here. and there would be our solution then. So here then is the complete answer in set notation, interval notation, and in form of a graph also. And note, it's a good idea to write 11/3 here because it's not a mark on the number line, so it's a good idea to indicate where that value is. Exercise number 25, based on information on page 103, the inequality absolute value of 3x plus 2 greater than or equal to 5 can be written as 3x plus 2 less than or equal to negative 5, or 3x plus 2 greater than or equal to 5. By subtracting 2 on both sides, we isolate 3x, and minus 5 minus 2 is minus 7, and then we divide both equations, both sides of the inequality by 3 to isolate x, so we get minus 7/3. X less than or equal to 7/3. On the right side, we subtract 2 to isolate the variable, determine the variable, 3x, and 5 minus 2 is 3. Then dividing both sides by 3, 3x divided by 3 leaves us x, and 3 divided by 3 is equal to 1. So x is greater than or equal to 1. That's the other solution. So then the solution set is the following. The set of all x such that x is less than or equal to minus 7/3, so 7 divided by 3, or x greater than or equal to 1. That's the solution here. Or the interval from minus infinity to minus 7 divided by 3, union 1, with a bracket of course, just as minus 7/3 gets a bracket because of the less than or equal, and that's to positive infinity, and of course again both infinities get a parenthesis. And if we were to graph this, minus 7/3 is a little bit more than minus 2 and 1/3, so it's a bracket here at 7/3, 7 divided by 3, and then we have the arrow going in this direction. And then the other part is from 1 with a bracket all the way to the right. So there would be the graph of the solution. This is the conclusion of section 1.6.